In this video, we're going to solve the 1999 Calculus AB FRQ question. It's a solids of revolution question. So it says, the shaded region R is bounded by the graph of y equals x squared and the line y equals 4 as shown in the figure above. Find the area of R. Okay, so that's not too hard. So now, area is going to equal, well, first we have to find the boundaries. So where do they intersect? 4 equals x squared. You're setting both these functions to one another. So x is going to equal plus or minus 2. So it's from negative 2 to 2. And now when you do this, you got to do top minus bottom to find the area. So it's 4 minus x squared dx. So now the antiderivative of 4 is 4x, and the antiderivative of x squared is x to the third over 3, and it's between 2 and negative 2. So now you're going to get 8 minus 8 thirds minus negative 8 minus negative 8 thirds. So basically you're getting the same thing. So now we're going to get 16 minus 16 thirds, which is 48 thirds, minus 16 thirds. So your areas can be 32 over 3, which is also approximately 10.667 if you round. I like the 32 thirds better. Okay, so for part B, it says find the volume of the solid R if it's revolved around the x-axis. Okay, so now if you revolve this, this is going to make a, I can't draw this. It's going to make a washer. So now you're going to get this. You're going to get this. It's making that washer. Can't draw it to save my life, but that's basically what it would be. So now, the volume is going to equal pi. Now we got to do outer squared minus inner squared. So it's still the same boundaries, negative 2 to 2. But now we're going to do 4 squared minus x squared squared dx, which is going to equal, from negative 2 to 2, 16 minus x to the fourth dx. Now we can and don't forget the pi. Okay, so now we're going to get the pi over here. So now we're going to get 16x minus x to the fifth over 5 from negative 2 to 2. Plug in 2, and now you're going to get pi 32 minus 32 over 5. Let me put that in parentheses. Minus negative 32 minus negative 32 fifths. So it's the same thing again because of that negative and that minus. So now we're going to get pi 64 minus 64 fifths, which is going to equal pi, what's that, 320 fifths minus 64 fifths. So our answer is going to be 320 minus 64, 256 pi over 5. Or you could say 160.850. So for part C, it says there exists a number k is greater than 4, such that when r is revolved about the line y equals k, the resulting solid has the same volume as the solid in part B. Write but do not solve an equation involving an integral expression that can be used to find the value of k. So basically what you have is, here's y equals 4, and this is y equals x squared. there's some arbitrary line over here, which is called K. And if you reflect it over, you're now going to get this. That's your outer. And this would be your inner. So it's making a washer. So I'm going to zoom out a little bit. That should be good. So now, when we find this, our volume is going to be pi, still from -2 to 2. Now we need to find our new radius. Our outer is from k to the bottom of the function, which is x squared. So it's outer squared, so it's k minus x squared squared minus the inner, which is k minus 4 squared, dx, which has to equal 256 pi over 5. And I hope this video helped.